Thank you. Bula Vinaka, everyone. I'll be presenting on the topic from collaboration to action and unlocking ocean data through Pacific Ocean Portal. So I'm Anuj Divesh from Fiji. I work as a senior systems developer in our ocean prediction and monitoring team at SPC. And this is the QR code in case you want to scan the ocean portal. Moving on, introduction. The Pacific Ocean Portal was initially developed in collaboration with the National Meteorological Services around the Pacific region to improve accessibility and delivery of ocean services through a centralized platform. Multiple key ocean datasets were identified and ingested in the portal, including chlorophyll, sea surface temperature, sea surface height, and many others. National Meteorological Services use ocean portals to create monthly ocean outlooks, provide tailored information for tourism industry, monitor tsunami events through real-time tide gauge data. It's widely used by climate scientists, and also the University of the South Pacific uses ocean portal in postgraduate level courses. Regional bodies regularly utilize the portal during Pacific Islands Climate Outlook Forums and for supporting fisheries management decisions through seasonal forecasting and historical data analysis. So just a bit of background. There was one Ocean Portal 1.0, which was developed by Bureau of Meteorology Australia in 2012 as part of the COSPEC project. So later on in 2017, there was a transition of this portal, a shift from Bureau of Meteorology to SPC in 2017. And that is how the ocean portal looked. So the code base, just quickly, it had Ubuntu 16, map server, it was containerized, and uses Python 2.4, and was deployed in AWS Cloud, Sydney. And it was, so you know, in Pacific Island countries, we do not have that good of internet connection, so we normally package the ocean portal in small computers, and we take it to countries to run trainings. So after some time, we had user feedbacks from countries requesting for many features in the ocean portal, including time series data. For example, if it's a forecast data, you want to see time series at a particular location on the map. In situ observation, ocean observations that are there, modern architecture, interoperable, real-time data access, and now all in one platform, because you know you have many dashboards and data can be sitting everywhere, and you have to open 10 links to get information. And scientific computing skills, access to global data sets, monitoring tools, access to ocean experts. So students at universities can contact these experts to get user input, and also the citizen science side of things, where you see some flood and you're able to upload photos in the ocean portal and form an archive. So collaboration at the core. So we started talks with the University of Hawaii, the Pacific Data Hub team from SPC, and some of the photos from there, also with NIWA, which is now known as Science, Bureau of Meteorology, and we gathered and we planned an architecture for this ocean portal. So then we came with a version 2.0. So what's inside? We are able to get datasets from a number of sources, including UNESCO, Bureau of Meteorology, CSIRO, of course, Pacific Community, NASA, NOAA, and Copernicus. And in some of the sectors, and we try to get this data and put it into some of the sectors, which include tourism, fisheries, corals, and ocean monitoring. So metadata, so we did some work and have data, where the data is coming from, what's the resolution, and things like that. Near real-time data sets like tide, sea levels, waves, weather observations, chlorophyll. And also we have forecasts like chlorophyll, phytoplankton, and currents, mostly from the European model. And historical data sets, sea surface height, sea surface temperature, and many others. And also hindcast data sets, mostly from Bureau of Meteorology, like the wave hindcasts going up to 1979. Just a messy diagram, so architecture view of what's behind the ocean portal. So at the bottom, we have the data store. So we have a Dexter, if you guys have had, and we have set up a Dexter to download data sets from the sources that I was just talking about. And we store it into different OGC servers, including ADAP, GeoServer, threads, and also we have looked into cloud-optimized formats for efficient rendering of maps. And then we have fast APIs, WMS, and Django as a middleware to create products in the ocean portal. And also we do a lot of monitoring of because we are not control of most of the data, so we have to monitor how things are changing and things like that. And also we do some data management side of things using Elasticsearch and PyOgeo API to index metadata in the ocean portal. So just quickly, what the backend looks like. So on that side, we can see threads with the number of agencies listed there. I think it's very small. Bureau of Meteorology, Copernicus, CSIRO, and others where we try to classify data as spots. And also GeoServer and some fast APIs to create tiles. And also we are using ADAP to have a store of ocean observations. Middleware, I just have a short video of what the middleware looks like, which is built in Django, which manages the whole ocean portal. For example, we have SPC member countries listed over here, and it's very easy to add a new country based on some bounding box information. So you don't need to change any code if you have to add a new country in the ocean portal. And also, we have a lot of download methods. Blue link adapter for NASA, Copernicus Marine, and HTTP download. So those are generic methods which are there. And these are the data sets we download in the ocean portal at the moment. And a data set looks like this with some prefix and the infix. Most of this time there's some changes in file names, so we're trying to, and subsetting it to the Pacific scale, and the variable, so we don't store the whole globe because this ocean portal is meant for the Pacific and things like that. And then we create maps, WMS maps, where we define all the properties of what we want to display, what style are we using, min, max, and all the things that is required to plot the map. So it's very configurable. And also we have that cloud optimized format. And we assign at SPC, we have a number of projects that is run through organizations. So we try to take those data sets to projects so we know where this data come from. And also we have widgets and themes, how we categorize these data sets. And also we do a number of monitoring with emails and also real-time dashboards of just seeing if the data is being downloaded and things like that. So the front end, when you open oceanportal.spc.int, we have a number of base maps. So we thought to come up with the SPC OSM base map where we download all the tiles and put it on the server so it's fast loading and also satellite. Just a look and feel. On the left, we have country selections. On the sidebar, we have some themes, and we have some layers from GeoServer, EEZ, coastline, specific names, and some specific styling. As you can see, when we zoom, there's more names appearing. And when you zoom in further, there's even more names of villages appearing on the map. So all this styling has been done on GeoServer. And likewise, we can see forecast, historical, whatever you are looking for, and it's available on that side. And then you click a data set, and you can add it to the map, and then it creates a plot. You can zoom to any location, and the map will re-render, and it's all WMS from threads. And you can click on a location to get the feature information, and also generate plots, which is often used in climate outlooks by the meteorological services. And then you can download this kind of plots. Also, we do metric and imperial units. Imperial units are used mostly in the Northern Pacific, so they can have things like in feet. And also time series and many other types of plot. And you can connect to our web services to access the data. Also, you can select a particular country. For example, I select Fiji. And now, when you create a plot, it creates on the fly for Fiji. And you can do it for any other country. And all this is done in Python. And you can share your workbench with what are you seeing, some phenomena with other colleagues, so they can see what you are seeing. And you can see we have other, so this is the in situ ocean observations. We're trying to get data from many places, such as PECAUS, Bureau of Meteorology, and many places. So this is like a sea level, and it's near real-time data sets from the Suva tide gauge. And you can have live mode to monitor sea level changes in cases of tsunami and things like that. Also, you can save your workbench, so you don't have to add your layers again and again, and it will know what layers you are always interested in. And also, we have collections, some other dashboards, which uses Ocean Portal authentication and is linked in the Ocean Portal. And also, we have a contributor page in GitHub if anyone would like to create a portal and host it in Ocean Portal. And also a library of tide calendars, wave climate report, and geodetic survey reports for the Pacific Island countries. So that's the front end. I'm just going to show a quick demo of what this is one of the popular requests we are having from the region, is to have all the observations in one platform and try to generate, you can, if there was a tsunami that's happening here, you can start clicking some stations and you can see how the waves are propagating to your country. So it's very widely used in the region. And then you can have this kind of dashboards. And the cool thing here is you can put this on a TV with a live button that you don't have to refresh your web page to get new data in. And what we are trying to do is to get some thresholds from these countries and send them alerts if these thresholds are being met. So you can do 72 hours and many others. And you can also share your dashboard with your colleagues to show them what is being, Also, moving on, in our oceanography team, we have a team of scientists who do high-resolution coastal models, which is very specific to countries. So this information are backed in a login. So once you log in, you can access to some country dashboards and access high-resolution. This is new, and you can see the fine resolution of waves that is being done by our oceanography team. which is used operationally by forecasters to forecast for big waves. You can click on a location, and this is very tailored. So we create this dashboard, and we went to the country and get their feedback, and we try to make it very tailored for their needs. And you can play it. And this is using unstructured triangular meshes, which is often very difficult, challenging to display. And moving on. Also, alongside Ocean Portal, we thought we collect a lot of ocean observations in the Pacific through various projects. So we came up with this. We are coming up with a system where you can search for data, which is held at our organization. So for instance, you can select a country and search for, and you can see the DEMs for Funafuti, for instance, and it is indexed with the PyGeo API and complies to all the standards. So this is some of the work we are doing. And as you can see on the screen, many bounding boxes around the region where we have collected some information, and that's where we are heading. You can, because many of the times users don't know what they want, they just know a bounding box, and they can query those data sets. And we have come up with a metadata format which complies with the standards, and here's how to create a metadata. And it tags with the data set. So SPC holds country data sets, so we can only release metadata, and data is released upon approval from countries. So that's why we only release the metadata. And have logins. Also, now that we have a good work in progress data management system, we thought of making this more, elevate this to global platforms like Wish 2.0. So for instance, a flow diagram which it shows here is like the ocean observations, which is often retrieved in the cloud. Then our data analysts, they can produce more parameters from those wave specters, and then it goes to SPC data management system, which is ADAP. And from there, we can connect Ocean Portal to show the near real-time and historical data sets, and Wish 2.0, because Wish, they only want to know what is happening right now, so near real-time data sets, we're hoping to push it to Wish 2.0. So that's our plan. This Ocean Portal was recently launched in the Ocean Conference, which was in Honiara a few months ago. So now that it's there, we are working on creating tailored products for stakeholders, integrate, there's many projects, so all of their data into Ocean Portal, also collect citizen science information, which is in progress, integrate more and more ocean observations that we are not aware of, and we are trying to talk to people and get those APIs and have it in the Ocean Portal. Also, centralized repository of ocean data sets, restricted and unrestricted. For example, one of the expensive data sets like LiDAR. And running training programs, connecting to Ocean Portal, creating products using Python. So our team is currently in American Samoa right now. They're doing a 1-week workshop around Ocean Portal with the National Meteorological Service. And also more consultation and awareness and feedbacks and for improvements. On the side, just to let you all know, we also have a Pacific Tides app, which was developed in-house by Pacific community, which has moon, sun, tide forecasts for Pacific Island countries. And it's 100% offline, normally used by fishermen that are out at the sea who don't have internet connection. And it's free and open source, and it can be downloaded at Apple Store and also on Google Play, so it's all cross-platform. And you can set specific tides to get access to this mobile app. And thank you very much.
Does anyone have any questions for our lovely presenter? Okay, I guess last one. What new features or data sets do you have planned?
So our team normally does oceans stakeholder engagements in countries. So we go and get their needs and come back at the office and try to create this kind of tailored products, which is very specific for this particular user. I'll just give you a quick example what we did. You know, you guys must be knowing about the Tuvalu Coastal Adaptation Project, which has just completed, I guess. They were doing some land reclamation. So the constructing company was asking about tailored information because they were moving these big barges across the ocean. So since we had a high resolution wave model, which is run at Tuvalu, so we created some tailored reports based on the needs in PDF format, and then we had those kind of public-private partnership where the private company was paying the Tuvalu Met service for the service which is provided. And before, they used to get it from other sources. So.
Thank you. Okay.
You mentioned that one of the data sets you're looking at bringing in is LiDAR. Are you talking bathymetric LiDAR? So if you're doing bathymetric LiDAR, would you also be looking at bringing in multi-beam data and any type of bathymetric data that you have available?
Yes, we are planning to index every...
Are you able to use that microphone on the region, please?
You can just speak from standing back, he'll get you.
Yep, we are planning to index any types of, we do a lot of multi-beam surveys as well, and we are trying to index it because there's a lot of data sets which is being sitting, in most places, so we're trying to manage it under one platform. So the work is in progress. And we have a team of people who are working on, identifying and filling this metadata we have identified and having this data available.
Okay.
And working together with also the PDH team, which is sitting at the back. Yeah.
Thank you. It's a very interesting talk. I've been working with the Vanuatu government with some of the datasets, and I would really love to connect with some of the APIs you have, some of the climate forecasting datasets. Is that possible to do, or does it have to be in the portal, or if we have our own, the Vanuatu government, they have their own management information system, can we connect to these datasets via an API, or is it sort of has to be in this portal?
No, it's very much possible. So how we design this architecture is everything is API based. So we have all these small microservices which is sitting outside this front end. And we had examples of Vanuatu when they recently launched their Met website and their mobile app. So they requested if they could use our backend and APIs to get the tidal forecast information. So we worked with them to get that. Yeah. And very much possible.
Thank you for coming to our second presenter, and thank you very much for presenting.